Hello world! Welcome back to another TryHackMe challenge video. In this video, we're going to be doing the Linux Server Forensics Room. Let's get started. You have been hired to investigate a data breach at Acme Web Design. Log into the target machine using SSH with the following credentials. And they give us the SSH credentials right here. As you can see, we already started the machine. And we're actually going to be tackling this from the attack box this time, right? And that's their built-in Kali box that you can use to attack machines. In fact, they prefer you do it that way because it's just, I guess it's just better. So let's go ahead and SSH in, why don't we? So we'll do SSH, Fred at 10.10.221.7. Yes, Fred rules, exclamation point. All right, we're in. So we'll go ahead and complete that task, and we'll move on to task 2. The most significant attack surface on the server is probably the web service. Fortunately, the Apache access log keeps a history, and it's cut off. But basically, the Apache access log keeps a history of connections made to the server. So that means that there's an Apache server on here, which means that there's logs that we can access to show who's or whatever's been sending requests and what those requests are to the Apache server. So source address, response code and length, user agent. Every request from a modern browser should contain a user agent string that can be used to identify it roughly. Content of the, I wonder if I can just exit split view for a second. Okay, it's still cut off a bit, but basically, we can also use this string to identify traffic from potentially malicious tools as scanning tools like Nmap, SQLmap, dir buster, and Nick2 leak their identities through whatever, right? So we'll show split view again. And so we need to navigate to /var/log/apache2. So for those of you who don't know, /var/log is where a lot of the logs are stored for a lot of the applications. So we come in here, Apache 2. All right, we'll see that we have our access log.log right here. Now, it did already give us some tools to look for, right? So I'll just go ahead and cat out the access.log so we can see what it looks like. See, this is what it looks like. But that's a lot to sift through and look at. So what we're gonna actually do instead is we're gonna go ahead and just grep for the things we wanna look at, right? So we're gonna say grep nmap access.log. And we got some hits on nmap. So let's go ahead and complete this task. How many different tools made requests to the server? So I did get a little bit ahead of myself there, but as you can see, Nmap is one of them. And let's go ahead and try, I guess, SQL map. So we'll do SQL map, no hits. We'll do Deer Buster. Nothing there. Maybe we need to do a little regex here, huh? So let's do tac E, and then we're gonna do capital D, D, IR, and then BB Buster. That way we can get any kind of caps that way we can read if there's capital letters, right? Oh, definitely got some hits there. And there's an and there, so let's exit split view for a second so we can see what the and says. And Nick2, that's right. So let's go ahead and look for Nick2. Okay. Nothing. All right, that's fine. Let's maximize the screen a little bit so you can see it better. Or maximize the font so you can see it a little bit better. All right, so it looks like just 2. That was correct. name a path requested by Nmap. So what we're gonna do is we're gonna go ahead and let's go ahead and full screen it, and then we're gonna regrep Nmap. That way we can get the full view of it. And it's looking for a path that looks like that, I guess. And the only one that looks like that is this one right here. The special path. Sometimes when Nmap's doing its scans and it's probing around, it'll send like some, interestingly formed paths to, test for information that it's looking for, right? So, all right, that's it for task 2. So let's go on to task 3. Web scanners are running against servers pretty much all the time, so this traffic is not out of the ordinary. Have a look around the site for potential attack vectors. What page allows user to update files? So what that tells, we'll go ahead and close this. Since this is cut off now, we'll go ahead and exit split view and open it back up so we get the side-by-side again properly. So we know there's a web server, right? So we can easily access that by just typing in the IP address that we use to SSH into up here, which would be 10.221.7. All right, and as you can see, here's the Acme homepage. So we're looking for the page that allows you to update files. So we can just click through all these and see if there's one that has like an upload option. Here we go, right here. See, there's an option for an attachment. All right, so that's the contact.php page. What IP uploaded files to the server? Okay, well, that's simple. We can just easily go back to our command line. That's not our command line. Here we go. You can easily just go back to our command line. And what we're gonna do, right? When you submit something to a website, usually you do it in the form of a post request. So we're gonna grep access.log for a post request. And you see we got 2 hits here, right? So that means that something was trying to be submitted in these 2 things, right? Now, there's no indication that it was a file that was submitted, but since these are only 2 options, then it's probably whatever the answer is here, right? So we'll go ahead and submit that IP address, and that was the right IP address. Who left an exposed security notice on the server? Okay, there's a couple ways to do this. Obviously, the security notice, if we go back to the website, sorry, not that. If we go back to the website, we'll notice that there's not really any security notices anywhere in here from the pages that we have available to us, right? But DIR Buster, remember, was ran. So maybe DIR Buster has some folders that us as users would not know about unless we, probed for them or crawled for them, like the attacker did when he was looking for, I guess, attack surfaces, right? So what we can do is we'll go ahead and full screen again so we can see it better, and we'll regrep our DIR Buster. And we'll notice there's static, and that's pretty common on websites. We'll take a look at it though. And there's also resources, and what else? Static resources, there's products as well, but I think that's one of the default pages. Yes, it is. Okay, so let's take a look at static first. So all we gotta do is type it up in here. Image. And okay, that's nothing. So the other one that we saw was resources. And there is some good stuff here. So we can just click through these. Okay, nothing. 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 Nothing there either. It would be this one, right? The last one. There's the security notice. So all we would need to do is open it and look at it, and we'll probably see who. We have really got to sort out the contact page. There's no validation whatsoever. I can't believe we haven't been hacked yet. Fred. Okay, so it's Fred who left the security notice. That makes sense, right? So the other way we can do this is we can simply just go to the source code of the website, right? And if you'll notice, there's, we actually have access to everything. We could go inside resources, right? We can go inside development, 2021, right? We can go inside CD 2021, CD docs, and there it is right there, right? And we can just cat it out. We can also, I think there's another spot it's in uploads. Oh no, that's something completely different. Well, there's the IP address that was doing the file upload to begin with, right? So that's good to know. I guess we could have found it out that way as well. And of course you have access, I think you have access to the locate command, so, oh, but you wouldn't have known what the security notice is called, so. Anyways, so now we know that it's Fred. So we'll go ahead and submit that. Awesome. All right, let's move on to task 4. Let's see. It looks like our attacker got in via remote file inclusion, RFI. It's best to look around the system itself for any evidence of... Close this and split view. Around the system itself now for any evidence of persistence mechanisms that could... So we got cron and Cron is one of the more common methodologies, so it's probably best to start there. Okay, so we're going to do exactly what it tells us, and we're going to start with cron. So we're going to show split view. Now, if you don't know where cron is, right, you could always do a locate. Oh, that's clear. You could always do a locate cron, and it's going to be probably in Etsy somewhere, right? So here we have a bunch of cron stuff, right? Now, cron tab is usually where you set up your cron jobs, so we're going to go to there. The file, so we just need to cat it. All right. What command and option did the attacker use to establish a backdoor? Well, as we can see right here, they use sh-tac-I, and there's the backdoor. Doesn't that look like that shell.sh we saw that was uploaded to the website? It sure does. So we got sh-tac-I, oops. And there we go, that's task 4. All right, task 5, here we go. It looks like the command from the previous task was set up to run under the root 2 account. This account doesn't make any sense as there should only be one root account. Wonder how it got there. There are a couple of locations where account information is stored on Linux distributions, including Etsy password and Etsy shadow. What is the password of the second root account? Now, you're only going to be able to examine Etsy shadow if you have root permissions, right? But Etsy password is always readily readable. So let's go ahead and read that and see what we get. Let's clear the screen first, though, so we can get better, clear visual. So cat Etsy passwd, and you got a lot of stuff here. So we'll just cat and then we'll pipe that into grep root 2. Ah, here we go. So the password hash for root 2 is actually exposed, right? Now we don't know what kind of hash that is, so what we can do is we can take that and we can actually, I'm gonna use my Kali box for this part. We can actually identify it by using this tool called hash identifier. And I can paste it in. Oh, well, sorry. Guess I have to do it like that. There we go. It recognizes it as a DES encryption, right? Or a DES hash. So that's a symmetric algorithm. So what can we do about that? What we can do is, okay, while we're in here, why don't we just go ahead and let's run John on it. Why don't we, right? So let's echo our hash, right? Into, let's say, root2 underscore hash.txt. And what am I doing wrong? Oh, That's right. I need a redirect. There we go. Then we just need to run John and do our format equals des on root. Probably need to specify a word list, but we'll try it without it first. Unknown ciphertext. Okay, so no des. There we go. Sometimes you gotta play around with John the Ripper until you find something that actually tries to crack it. All right. We've got a cracked hash of Mr. Cake. So what is the password of the second root account? Mr. Cake. All right, so now we're gonna move on to our second machine, I guess. So we'll go ahead and terminate that one. And we'll start this one. And while that's starting, we'll read the next prompt. Wow, it looks like they got hacked again. Better have another look. The credentials are the same as last time. Guess he didn't learn his lesson. All right, so let's go ahead and clear. All right, it looks like our second machine is finally deployed. So let's go ahead and SSH in. And I need to make sure to do Fred, right? Yes. Fred rules, exclamation mark. Okay, Fred rules. There we go. All right, we'll complete that task. All right, task 7. The log file is a lot smaller this time around, so it looks like our attacker was a little more subtle. There also don't appear to be obvious user agents anymore. Fortunately, there are a few other ways of identifying traffic originating from scanners. The time between each request is a good metric for most tools. You can also identify individual tools from signatures left in the requests. For example, Nmap will send HTTP requests with a random non-standard method when performing certain enumeration tasks. More aggressive tools can also be identified simply from the number of requests sent during any given attack. Directory brute forcing tools are a perfect example of this and are likely to fall foul of banning systems like fail to ban. A poorly designed site may also freely grant valuable information without the need for aggressive tools. In this case, the site uses sequential IDs for all of the products making. It easily scrapes every single product or finds the total size of the product database by simply increasing the product ID until a 404 error occurs. Name one of these non-standard HTTP requests. All right, so what are we gonna look for? We're looking for HTTP requests, right? So we're gonna go to var log again, right? In our Apache file, right? We're gonna take another look at our access.log, right? Because that's gonna have all our HTTP requests in it. And we're gonna go ahead and show full screen so we can get the full picture of it. So we're looking for a non-standard HTTP request. So if we scroll up, we'll actually see. So here's all the HTTP requests, right? Get's normal, right? Options is normal. And if you scroll down, post is obviously normal. But then you'll notice there's a GXWR, and that's definitely not normal, right? There's no header that's called GXWR. So that's gonna be our non-standard header. At what time was the Nmap scan performed? So how are we gonna find that? Well, let's see if there's an actual reference to Nmap, right? So let's go ahead and grep for Nmap in our access.log. Okay, no results. So how can we get when the Nmap scan was performed if there's no reference to Nmap? I guess we can probably try grepping for the IP address associated with that GXWR, right? Since we know that's the IP that's launched the Nmap scan, right? Whatever the first entry should be the actual scanning request, right? Or the starting scanning request. In theory. It may not be, but it should be. So let's go ahead and do that again, but this time we're gonna do it with our IP address. Binary file access.log matches. Okay, So it found something, but we're not getting the matches back because it's reading it as a binary file, or it's seeing it as a binary file. So let's see if grep has any kind of special thing we can use to read binary files. Ah, here we go. TAC A, equivalent to TAC binary files equals text. Okay, so it looks like TAC A will give us exactly what we want. It'll specify that this is a binary file that we are looking at. So if we do that, yep, we got some feedback. So the one we want to look at is the topmost one, right? And that should be our starting scan packet, essentially, right? So let's go ahead and, I guess, copy this out. Time was the scan performed. Okay, so it just wants the time specifically, and that was right. Awesome. So I guess our assumption turned out to be true. Let's move on to task 8. The adversary has been a little smarter this time around. If any backdoor exists, it's likely to be more subtle. SSH keys are another excellent way of maintaining access, so it might be worth looking for additions to the authorized keys file. Okay, so it's verified that there's an authorized key file somewhere, right? So we can go back to Fred's home directory and we can actually do ls tac al. And the tac A is what shows hidden files and directories. And anything that's hidden is designated by a period next to it. And what we're looking for is .ssh, right? So if we didn't have that tac A, we wouldn't be able to see these. And if we open up the file system, we also wouldn't be able to see these without, changing the settings to where it shows hidden files and directories. So I don't see .ssh in here, but I do see a sudo as admin successful. So I'm wondering if we can actually just switch to root and then go check his home directory out to see if a .ssh folder is in there. Because if that's the case, that SSH key is much more valuable because root is what you want to get to have elevated privileges on a system to do whatever you want with. So if you can log in with it, you're set, right? You have full control of the system, which we don't have just by the normal user Fred, right? So let's see if we can't sudo su, which is gonna take us into, or switch to root, right? And we'll try Fred rules. All right, we'll try that again, Fred rules. It worked. All right, so to get to the root's home directory, we could do cd tilde, but it's also just /root, right? We do ls, oh, right, we gotta do ls tac a. We'll do al so it lists it nice and neatly. Yep, there's a .ssh directory, so let's go ahead and cd into it. And there's our authorized keys file, right? So it's saying what username and hostname combination can be found in one of the authorized key files. So let's just cat it out and see what we got. If we scoot it over to the right here, we'll actually see the username and hostname combination at the very end of the file. So we'll take that, paste it in, and we're square. All right, let's move on to task 9. Of course, adding a public key to root's authorized keys requires root level privileges. So it may be best to look for more evidence of privilege escalation. In general, Linux stores a tiny amount of program execution history when compared to Windows. But there are still a few valuable sources, including bash_history contains a history of commands run in bash. This file is well known, easy to edit, and sometimes disabled by default. Auth.log contains a history of all commands run using sudo. History.log apt contains a history of all tasks performed using apt. Is useful for tracking program installation and removal. Systemd services also keep logs in the journald system. These logs are kept in a binary format and have to be read by a utility like journalctl. This binary format comes with some advantages. However, each journal is capable of validating itself and is harder to modify. What is the first command present in root's bash_history file? Okay, so let's go ahead and clear. And we need to scroll back over. cd ... So we know that bash history we saw it when we did our tac A earlier. We have it right here, right? It's a hidden file. So all we need to do is cat bash_history. and we'll get the first command as nano etc password, which is probably how root 2 was able to add its own entry into that file. All right. So now we're moving on to the final VM. So I'll get back to you in a second when it loads. All right, it looks like our box is loaded. So let's go ahead and SSH in again. This is getting a little annoying now. The credentials are still the same. All right, so we know that we can just get in like how we have been. Fred rules. Okay. Yep. All right. Complete. All right. Final task. Malware can also maintain persistence using systemd as scripts. Run under systemd can run in the background and restart whenever the system is booted or whenever the script crashes. It is also relatively easy to conceal malicious scripts as they can blend in with other services. Systemd services are defined in .service files, which can contain the command that runs whenever the service starts, the user the service runs as, and an optional description. In this case, the malware is pretty obvious as it seems to be printing errors to the screen, so there is no way that it is dormant. Running systemctl will list all of the services loaded into the system, and much like Windows, there's usually a lot of them. It might be worth adding --type equals service --state equals active to the command, as it will reduce the list to services that are running. Once the name of a suspicious service is found, more information can then be extracted by running systemctl status service name. Figure out what's going on and find the flag. Okay, so they basically gave us our path to success here. We notice on our screen we are getting spammed a crap ton by error messages and other random crap, right? So this is going to be a little bit annoying to type into because it's probably going to lock up it's locking up my terminal. So we're just going to simply type what we need to do in here and then copy and paste it in the other side, right? That way we don't, whoops. Let me, split view, show split view. That way we can see everything now. There we go. Okay, so we need systemctl type equals service state equals active, and we'll copy that. Quickly paste that in and press enter. All right, so we got all the active services loaded. Now there's a lot, and you'll have to go through each one to find out, which one is the one we're looking for. But there actually is one that's kind of sneaky. If you take a real close look at all of these, and I'll go ahead and load the rest of them up here. All right, there's 62. If you scroll up, there's only one that actually has capital letters in it. And it's this ipmanager.service. It's the only one out of all these active services that has any capital letters in it. Not only that, if you look at the description, it says loaded active running ipmanager.service. All these other descriptions actually, give you a much better explanation of what they do, right? So like the Apache 2.service, right? Running the Apache HTTP server, or cron.service, active running regular background program processing daemon, right? So this just says running ipmanager.service. There's nothing legit about this. None of these other active services actually even mimic this format. They actually have real descriptions, but this is just saying it's running the service. So that's very suspicious. So ipmanager.service is probably the one we want, right? So we're going to do systemctl status ipmanager.service. I didn't type it in time. Let's see if I can get it. Systemctl status manager.service. There we go. Got it. But I didn't get it in time, I guess. Oh, there we go. All right, so that the status. Remember, the status module for systemctl is what we're going to run to get more information, right? And if you drill down here, you'll notice that there's actually a command and a script associated with it. Let's actually see what this is, because that's probably going to have our flag in it. Oh my gosh, this is annoying. There we go. All right. So yeah, here's all those freaking error messages. All the wall command does is it prints out whatever, you know, comes after it as an argument to any logged on user's terminal, right? It goes across all the terminals. So it's annoying. That's exactly what it's doing right now. Yeah, you'll see even more error messages, and these are just print statements. That's kind of annoying. But if you look up and the first line of the file, ghost in the machine in brackets, that looks like our flag, I think. Whoops. So let's submit that. And we completed the room. We went through 3 different accounts on machines for Fred. There's all kinds of things to look at in Linux that are much easier to access, you know, depending on the permissions, right? Or the holes in permissions, than it would be in Windows. Anyways, I hope you enjoyed the video. Drop a like, subscribe to the channel if you want more content like this. Check out our Discord server and Patreon links in the description box down below, and leave any feedback on the comment section down below. This is Almond Milk, and I'll see you in the next video. Thanks for watching. Goodbye, world.